Okay, we're going to try and solve this trig equation, but instead of using an adjusted domain, we're going to use a general solution method. So let's see how we go. So we're looking for somewhere in the unit circle where we get a solution of -1/2. And that's going to be here or here. And it's symmetrically the same as the basic angle π/6. So if we go around the unit circle anti-clockwise from 0 to our first solution, we can see that that's π plus π/6, which gives us 7π/6. If we go around from 0 to the other solution, we're almost all the way around to 2π, but we're back π/6. 2π really is 12π/6, so this solution here is 11π/6. So if we go once around the unit circle, we get solutions of 7π/6 and 11π/6. But we're not looking for one solution, we're looking for every solution. So we need to go around the unit circle an infinite number of times. So let's do that here. We're going around to 7π/6. If we go all the way around the unit circle and go 7π/6 again, that's really 2π plus 7π/6. Go around again, it's 4π plus 7π/6. Go around again, 6π, etc. So really we can write that solution in a general way like this: 2nπ plus 7π/6. We can do the same with the other solution. Go around to 11π/6, go around the unit circle again, and it's 2π plus 11π/6. Go around again, 4π plus 11π/6, and so on. In the general case, we're going to get this solution: 2nπ plus 11π/6. So now we can add π and 4 to both sides. Since these are fractions, we've got to find a common denominator. I'll use 12. 6 into 12 is twice, so that's really just a 14π. 4 into 12 is 3, so we get 3π. That becomes a 22π. Okay, clean that up. So this is all equal to 2x. To find x, we just divide by 2. And maybe it's a good idea to have that all over a common denominator. So there's a general solution for this equation, and it's really important here to say that n is an element of the set of integers. So it could be any negative number, 0, and any positive number. So there's our general equation. or our general solution rather. But in this question, we have a restricted domain. It's minus pi to pi. So how do we find the solutions just for that domain? We can start with n equals 0. In that case, we just get (17 pi and 24) there. If this is 0, this n, we'll just get 25 pi and 25 pi on 24. But you can see there already that's outside the restricted domain. That's bigger than pi. So that's not going to be a solution. And because that's not going to be a solution, it makes sense not to go to n equals 1 or n equals 2, because there are not going to be any more positive solutions around that part of the unit circle. So let's go backwards to n equals minus 1. That gives us solutions of negative 7 pi on 24 and pi on 24. So we've still got some solutions to go. Let's go over here and we'll try n equals minus 2. n equals minus 2, and x will equal multiply 24 by minus 2, 24 by minus 2, we get x equals minus 48 plus 17, minus 31 pi on 24, and minus 48 plus 25, minus 23. So 23 pi on 24. Now remember, our restricted domain is minus pi to pi. Clearly minus 31 pi on 24 is too big, but minus 23 pi on 24 is within that domain. So if we look at the solutions that are in the domain, and we don't need to go any further because once we've got that solution, we know there's not going to be any more. So within the domain minus pi and pi, our solutions are 17 pi on 24, pi 24, negative 7 pi on 24, and negative 23 pi on 24.